Hello, 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 hello. Good afternoon, everybody. How are you? Welcome, everyone, to office hours for Unit 1, Data Science, World Quant University. So excited to see so many people here. I see Samir is here. Salam alaikum, wa alaikum salam. Kampala is also here. I see, I like the way Emil says it. Brothers and sisters in data science, glad you're all here. How is everybody doing? Okay. I already see a few questions coming into the pipeline. Let's start writing them down. I see someone is interested in the difference between classes and objects. All right, good. What other things are people interested in discussing? I see somebody wants to look at the mini project, so we can definitely look at the mini project. What else? What else are you guys interested in looking at today? People want to look at recursion and memoization. We can definitely do that. All right. Excellent. Complexity analysis. I don't know if we're going to get into all of the details of complexity analysis, but we can certainly look at it a little bit. I see Zambia is sending some love. Okay, well, we can definitely talk about Big O. Big O. Beautiful. What else are you guys interested in looking at today? Tell me, tell me. A lot of people are interested in classes. I can see. That's great. I'm really glad to hear it. And complexity analysis. I see complexity analysis is coming up a lot today. And the IP mini project. Okay, great. Well, I love all of this. Let's check it out. Okay. Yaya wants to look into scikit-learn. I think scikit-learn is a little bit beyond what we're going to be doing today, but what I'm going to do is looking at everyone's various things that they want to look at today. I'm going to start by talking about classes and objects. So I'm going to start with classes and objects, and then I'm going to talk about complexity analysis. And then I'm going to move into the mini project. And depending on the time we have left, I can do recursion and memoization. And if we don't have time for memoization today, what I will do is I will make sure that we look at it tomorrow. So if we don't get to today, we will definitely do it tomorrow. Let me just open up my algorithms notebook. Okay, great. So let's start at the beginning, shall we? I'm going to open up my Jupyter Hub and I'm going to go to Home. And then from there, I'm going to go to Data Course. And we'll start with Python. And I'm interested in looking at classes. Let's see here, that's not there. I'm going to go to Data Wrangling. Here we go. Data Science Classes and ORM. Now, the other thing that I'm going to do is I'm going to open up a new notebook, just so we have a clean copy to work with. And I'm going to rename it. I'm going to call it DS Office Hours, and that way I can share it with you guys later. All right, so let's start at the beginning. Everyone is interested here in classes and objects. So let's take a look at that. All right, so I'm going to go back to the classes in ORM notebook. And what I'm going to do is I'm going to just copy and paste the person class that Dylan, the instructor who's in all of the videos, talks to you guys about. Now, the best way to think about the difference between a class and an object is that a class is a blueprint. It is a plan for constructing an object. So, what's the difference between a class and an object? Well, if I look at type and I look at person without parentheses, it's going to say type. That's funny. Okay. It's actually just going to give me a type. It's not going to give me a class here. But it's basically What a class is it is a battle plan. It is a blueprint for the creation of an object. And an object would be when you bring a given class to life. So, for example, if I were to just type in person, I'm not going to get anything back. It's just going to say that there is a class, its name is person, and that's all I know. So that's what we have here. This is the class. But the moment that I instantiate or create an object using the person class as my blueprint, things begin to change. For example, I'm going to create a new object, and I'm going to call it N. And I want it to be a person. So I'm going to say look into the person class. And the name is Nicholas. The age is 39. The degree is uh, PhD, and the salary is $30 a year. You didn't think I was really going to tell you my real salary, guys, did you? And so what I'll do is as soon as I run this block of code, what's going to happen is the Python interpreter is going to look at this blueprint, and it is going to say, all right, what is it I need to do in order to create a person object? So I'll go to the class definition, and using that definition, I will create a person. Saud says 30K per month. I wish, man, if it was 30K per month, I could retire soon. All right, so now I have this thing called a person. So this is an object. And if I were to look at the type, it's going to tell me that it is a person, which is the same thing I get if I just type in person. So this is referring to the class. And here, this is also referring to the class, the type and the type. But now N is an object of type person. Now, objects can have lots of different things associated with them. They can have lots of tools that are part of what they do. So, for example, an object can have what's called an attribute. And an attribute would be any characteristic that is stored as part of that object. For example, if I do n.name, it's going to return a string. And the string will be Nicholas, which is my name. So we can say that the name attribute for the n object is Nicholas. Likewise, we can say the age attribute for the n is 39. And the other thing that objects can have besides attributes are methods. And methods are like functions that work within an object. So for example, if I do n.describe, it's going to print out a string that'll tell me my name and how old I am and the degree I hold and the salary. Now, Charles is asking a really interesting question. Charles wants to know, what is the difference between a property and an attribute? Well, I don't think in the context of this topic, I don't really see a lot of difference between those two words. What I would say is that the word I would use is attribute, which is any sort of characteristic that you assign to an object. So name, age, degree, and salary are attributes. You can call them properties, but generally we call them attributes. Now, Mikal has a question about is there inheritance in Python? And yes, there is. And we can talk more about inheritance, but I think it would be better to put a pin in that, and we can talk about it more when you guys are working with NumPy and Python. Now, here's a question. Do you guys see a difference between the syntax here for, oh, another great question. So someone is asking, what is this init function here, this init function? Great question. So the init function is when I do this instantiation. So when I tell the Python interpreter, create an object based on this class, the function that it will run is called the init function. So like Saud says, it's a constructor. So what it will do is it will create the person object. And in the case of this init function, it will assign all of these values, the name, age, degree, and salary, to the different attributes that are part of the person object. And self refers to the object itself. And what happens is it's the same as if I were doing describe n. Actually, that won't work. Basically, um, it allows you to uh, access the different methods that are associated with an object. Yeah, that's it. It allows you to access the methods that are associated with it. And someone wants to know whether we can use another name for the init function. And no, you need to have the underscore underscore init underscore underscore. But I could do, yes, I think Andrea's right. I could do person describe n. Let's see if that works. It does. Beautiful. So it has to be init. It always has to be init. And someone wants to know what is the meaning of these underscores. Sometimes these are, when you see two underscores like this, in English we'll call it a dunder. I don't know why we call it a dunder, but it's often called a dunder. And it's just a convention in Python. So it doesn't mean anything by itself. And Andrea is right. Here, self is, it's a convention as well. I could use another name, but just by convention, we stick with self. And the reason that we have object here is because we are telling, actually, I wonder if you need to do this anymore in Python 3. Let me, hold on one second. Yep. In fact, you don't need the object. You don't need the object here. That was just a convention, I think, in Python 2 or an earlier version of Python. So I think you're okay doing just this. So Andrea is helping me out a lot today, for which I am very grateful. But dunder is short for double underscore. Thank you very much. Thank you very much. And Joyce wants to know what FMT is. Another great question. So if we look at FMT, we can see that it is a string. And inside that string, there are several different sets of curly braces. And what happens is if I go return the name of the string dot format, and then I provide a bunch of different arguments, it will fill in these blank spaces with those respective values. And so that's how I can start with a string that looks like this, but when I actually do my method's describe method, it will actually fill in everything. And Andrea's suggesting another way of doing this. And the way that you're describing, Andrea, I'm not going to get into it, but yes, it's definitely possible. This is just, there's several ways to work with strings in Python, and this is one way. And Purushottam is talking about using these underscores for public, private, and protected functions. That's not exactly, there are conventions that communicate it, that communicate whether something is supposed to be a private function or a protected function, but actually they're just conventions. There's nothing hard in the syntax of Python which actually keeps these functions protected. So FMT is a string where there are little placeholders that are filled in as soon as I use the format method. And Yahia wants to know, how can Python know the value of my age is 39? And the reason is because person, when I instantiated my person object, I gave it that information. I gave it my name, I gave it my age, I gave it my degree, and I gave it my salary. All right, now back to the question that I had before, which is, what is the difference you see in the syntax between age and the syntax with describe? What difference do you guys see? I see one answer from Bishoy. I see an answer from Tiger as well. Gerald, exactly, exactly. You guys have great observations here. So when I'm accessing an attribute, there's no parentheses. And when I access a method, there is a parentheses at the end. So um, an attribute doesn't have parentheses. So any characteristic of your object doesn't have any parentheses. But if you use a method, and I see some people calling it a function as well, it is a kind of function. But because it's a kind of function, when I have a method, I do include those open and close parentheses. So with an attribute, I'm asking for a characteristic of the object. And when I use a method, I'm asking my object to do something for me, which in this case is return this string, which has my name, age, degree, and salary. So attributes, no parentheses, and methods, yes with parentheses. Okay, well, we've talked a lot about classes, and what I'm going to do is I'm going to move over to complexity. And I know that there are a lot of questions left for this, particular programming challenge, classes and objects, but I want to make sure I get to as many questions as I can today. So we can always come back and do more work with these in the future. Okay, so I'm going to go back to data wrangling. And from there, I'm actually going to go back to data course, Python, and then Pi algorithms. Give me 1 second, guys. There we go. Just getting my screens in order. Okay, so let's talk a little bit about computational complexity. And we'll talk a little bit about big O. So big O is simply a way for programmers to determine how long it takes for a certain algorithm to execute without having to worry about differences between machines, whether there's a difference in the operating system or the compiler or the memory or the processor or any of that stuff. It's sort of a lingua franca to talk about how long it takes your computer to execute lines of code. Now, let's start with the example here in the notebook. I'm going to run all above. Now, let's take a look at this first function here. Now, what I want to do is I want to sum all the numbers between 1 and then a given number that I give it. So if I give it 10, I want to sum all the numbers between 1 and 10. In this particular function, first we define our function, we set our sum as 0, and then we do a for loop. And we do that for loop over a range that starts at 0, yep, and it goes all the way up to n. And in each of those loops, what it will do is it will take the new number, whether it's 0, 1, 2, 3, etc., and then it will add that number to the sum. So the sum starts as 0, and then n will be 1, and it will add 1, so the sum will be 1, and then it will add 2, so the sum will go from 1 to 3, and so on and so forth. Now, if I add a new cell here, and I go sum number 10, and I see that the answer is 55, how many operations, how many calculations does my computer need to do in order to complete this algorithm, to complete this function? I see a lot of 10s, and you guys are absolutely right. It's going to be about 10. And so what we're saying is, and if I increase this to 20, it'll take about 20 calculations. And if I do 30, it'll be about 30. And I see someone saying here that this is linear. It's linear, and you're absolutely right. So if I were to go to my, hold on, there we go. Where is my keyboard shortcut here? There we go. Beautiful. If I were to draw this, right, as, and then here on the bottom would be, here would be N, and then up here we're going to put O for operations. How many operations will it have to complete? And the line is probably going to look pretty straight. Which means that as N gets bigger, so will O. So will the number of operations, and they'll do so linearly. And that's what it means when we say, oh, this algorithm is ON complexity. ON complexity. And this is linear. So it's this first case, some none, excuse me, some num, some number. So it's about order n, order n. Now, if I scroll down, there's another example where the algorithm has changed, where if I look at this mathematically, or if I change the math behind it, and I don't have a for loop, by using this formula, I can also get the same answer. So if I do sum num 20, I'm still going to get 210, but how many operations does this Gauss formula, this sum Gauss function do? If I put in 20, how many operations or calculations does it have to do? Andrea says 1. What does everyone else say? Kingsley says 1. It's just 1. It's just 1, basically. You guys are all right. And if I make this 20, or I make it 200, or I make it 2,000, it's still going to be just one operation that's going to be included here. It's just one line of code. It'll be done, and that is it. And so if I were to go back to my thing here, the time complexity for our Gaussian is actually going to be just a straight horizontal line, and it will remain constant. See if I can, whoops, hold on. Well, it's not, my lines aren't very flat, but that's okay. So we can think of this in number of lines of code. That's a good way to think about it. Lines of code that are being executed. And so here we can say that the algorithm is order 1 because it doesn't matter what the size of n is. And if we were to plot these two, this will take a second to run. We can see that this is exactly how it works. Our Gaussian model is going to stay constant no matter how big n gets, whereas our sum of numbers is pretty much going to be a straight line. When we think about lines of code that need to be executed and the time it takes to execute it. So that's what we need to know when we think about complexity. And let me see if I can find a good resource on this. There we go. Beautiful. And there are all sorts of different time complexities, but the important thing to remember is that some are good and some are bad. Right? Here's our ON complexity, and that's pretty good. But if I could get, but we can see what's really good is O1, and if you can't do that, doing O log n is very good. And where you really want to avoid is if you have something that's like a complexity that's like ON squared, or even worse, O second to the n power. So for you guys, this is really about thinking, how can I optimize my code so that no matter how big or how much information I throw at it, it won't take that much longer to run as I increase the amount of data that I push into it. So that's what's important to remember about big O complexity. And I did see someone asking, what is matplotlib? Great question. Matplotlib is a library that you use to create visualizations. So matplotlib is what allowed us to make this pretty picture right here. And Saud has it exactly right. The best case is O1, and the worst case is O N. Crud. How do you say it with the exclamation mark? I'm blanking. I'm blanking. I'm sure someone here will fill it in. So matplotlib is a whole library that gives us a whole bunch of different n factorial. Thank you. That's absolutely right, Saud. Thank you. 10 extra points for Saud today. Thank you, everyone who's. Thank you, everyone. The great thing about doing these office hours is I know that if I forget something, there'll be like between 50 and 100 people who will correct me or who will help me. Now, what I would just point out here about the code is that when we import matplotlib, it's going to give us all sorts of cool tools that we can use. For example, here I import it as PLT, and down below, you can see that I'm doing all sorts of cool methods with it. So I have the plot method where I'm plotting two different lines. I have the xlabel method where I can label the x-axis of my drawing. I can also label the y-label, and I can add a little legend or a little key in the corner. So we can see how we use methods and attributes in everything in Python. whether it's in classes that we build ourselves or whether it's in classes that come from different libraries, as is the case with Matplotlib. Okay, we've talked about big O, we've talked about classes and objects. I'm going to skip over memoization. I will touch on it tomorrow, but for now, I want to look at the mini projects. Now, what is the mini project that we're doing today? Is it IP? Yes, it's IP. So let's look at IP here. I'm going to first restart and clear my output. If you're curious about what we've done up until now, we've been looking at this in the office hours for the last couple days. So check out the office hours for yesterday and the day before. We've figured out our Mercy number function. We figured out our isPrime function. And we were working on our Lucas Lemmer function, which we completed. And then I believe we were working on number 3 or number 4. I think we were looking at number 4 now. And you can also play with it in the notebook. That's absolutely right. So let's take a look. Let's start with number 4. Okay. All right. So I'm going to go to number 4. And the first thing I'm going to do is I'm going to go cell, run all above. I'm not so worried about this. There we go. And next, we are looking at the optimizing our isPrime function. And this gets back to what we were talking about earlier in office hours, which is, can we improve the complexity of this so that we can be faster? Because, for example, if I go to my original isPrime function, which I created up here, the most of the function is all about this for loop where I test every single factor between 2 and the number that I'm testing. So if I'm testing number 5, I'm going to be testing 2, 3, and 4. So it's not the final number. It's 2, 3, and 4 in the worst case scenario, right? And so again, Michael, you're absolutely right, or excuse me, Mikal, you're absolutely right. The complexity here is ON, which is good, it's fair, but it's not great. So the question is, can we do better? And of course, we can always do better. We're data scientists, right, guys? So let's take a look at how we can make this a little bit faster. I'm going to scroll down. And there are two things that we did already. We had two if statements to kind of take out the garbage cases or catch those before we have to do any real big computations. The first is, if the number is less than 2, we return false, because we know it's not prime. If it's more than 2, our second one is, if it's more than 2 and it's an even number, that is to say it is divisible by 2, well then we know it's definitely not prime, so we return false there. And 2 isn't included here because we have more than, we have less than and more than. We don't have equal. And what we know that, based on the instructions, we know that, well, what is it that we know? Tell me a little bit. So we need to compare the square root of the number with its factors. Okay, good. So let's think about how we do that. I think it's going to be similar to what we did before in the sense that we're going to go for factor. You know, uh, Kamara raises a really good point. Maybe we don't even need this if it's greater than 2. We could probably remove it. Well, let's keep that in mind. So I'm going to go for factor in range. I'll remove it. You're right, guys. Let's remove it. I love it. We're already making our code a little bit more efficient. And then the next is I'm going to do range 3. And let's see here. How do I want to do this? I like some of these answers. So I'm going to type in some of them. I'm going to say int. So I'm going to make it an integer. And then I'll do math dot square root of my number plus 1, because I want to include that last one. And I'm going to go by 2, because I don't need to check the even numbers. I love that. And then if the, if the number modular divided by the factor equals 0, I can return false. And then if it gets through all of these, then I can finally return true. Now, Yagya is saying that this will return 2 as a prime number. Let's see if that's true. Is prime fast 2? Interesting. Very interesting. Ah, right. That's why we had the second if statement here. That's why we did it like this. You're absolutely right. Thank you, Yaya. Uh, extra points for Yaya, bonus points. Let's see here. Why is this giving me a string error? That's very odd. Int can be converted to non-string with explicit base. Int square root number. I'm just troubleshooting my code here. And I'll also put this here. There we go. Okay, beautiful. So we are all set. Okay, guys, so let's try it. Let's just make sure they work. Okay, so I see that is prime and prime output the same things if I put in many different assertions for them. And now let's see what the difference is in terms of the time. So we're going to compare our is prime with our is prime fast on a very large number, 67,867,967, which actually happens to be my lucky number. Now Tiger is asking, how do we check if 2 is prime if the range starts with 3? Great question. Well, we know that true is prime. Excuse me, we know that 2 is prime. And so if we get a 2, it will skip this if statement. It will skip this if statement. And we'll end up here. Okay, let's look at the difference. So for our is prime function, which had an O complexity of, it had a time complexity of order n, it takes 5 seconds, give or take a few milliseconds. And for our is prime fast, it takes 301 nanoseconds. So that is way faster, way faster. Way faster. So we've come up with a great way to improve our time complexity by using this little bit of square root magic. And if I scroll down, I need to do the last part of this, which is I need a function that's going to return all the prime numbers up to and including n using my is prime fast number. So how would I do this? How would I do this? How would I start? What do you guys think? I see Tatanka is curious about the math library. The math library has all sorts of great things in it. There we go. And I'm just going to copy and paste this here. But yes, it has all sorts of wonderful trigonomic functions and all sorts of cool things. So if there's some sort of math you need to do, you can always look for it in the math library. Now, coming back to our idea, I'll do an empty list. Sure, I'll do an empty list. Results is an empty list. And then I'll do a for loop. So for n in what? range, and here I can put n plus 1. And then what? I see some if statements, so I could do if is prime fast n append, whoops, I would do results append n. And then at the end, I could return the results. So let's just see what that looks like. So get primes fast up to 365. What do we do originally? Up to 65, right? Okay, good. This works. And what I would like to do is I want to take this code and I want to make it smaller or use less lines by using a list comprehension. Charles is wondering, why not a list comprehension? I see everyone shouting at me, but a list comprehension. I know, guys, I'm going to get there. I just think it's important to be thinking about if loops, but then also for loops, but then also list comprehension so we can see the equivalency. So I'm going to change, instead of having an empty list, I'm going to put my list right here. And for my for loop, I'm going to put that at the inside my comprehension. And I'll also put n, what I want to append. N, in this case, that goes at the beginning. And then my if statement would go at the end here. So the empty list becomes this list here. The for loop is here in the middle. The if statement is here at the end. And the operation, which in this case is just returning n, goes right here at the beginning. So I can take all of this and delete it. And I can run my function again, and I get the same thing. And if I hit Shift Enter and I scroll up, I can see that my score is 1.0. Beautiful. So what we've shown today is if you look at your code, and there are ways to mathematically lower the number of calculations or like lines of code that you need to execute, you can greatly decrease your time complexity and increase the speed with which you complete things. And we can see that here. I mean, it's way, way faster to do our get primes fast function. And that's how we've been able to get the answer to number 4. Okay. Well, it looks like we have come to the end of another wonderful office hours. I want to thank everyone for all of your questions. For those of you who were asking about memoization, I'm sorry that we couldn't get to it today, but I will definitely get to it tomorrow. Just remind me. And I'm so glad that you guys are helping me with all of these, and I hope that I'm helping you. And it's just wonderful to have this global data science community where we're all helping each other get better. So I can't wait to continue the conversation tomorrow. And until then, I hope your life is not complex. I hope your life is O1 complexity and not ON squared complexity. And remember, I'll see you next time. But until then, happy data science. Bye bye, everyone.